right here. I mean, this is obviously
yeah, I think that's. I'm just trying to look if I can see any previous years.
are you seeing my screen?
Yeah.
Okay, like this is there's a number of questions like this. Is this a good, I mean, is it okay if we do some problems like this, or
Yeah, that's fine.
I
I can send over for tomorrow stuff that he has given us.
so do you want to try working this out, or do you want me to work it out?
Can we go through it together first?
Absolutely. So with U substitutions, they're actually giving you the U. I probably wouldn't give you the U in this case, but they're saying U is 3x minus 2, and then your du is 3dx. Okay, so that's all good. You go and you say, okay, it's really sine of U, and then dx is really du divided by 3. So there's a du divided by 3 here. So it's 1/3 integral sine U du. And so that gets you down to, you know, C, D, and E. You're supposed to change the bounds when you do U substitutions, which means that you want to plug in 0 and 3 into the U here. So U of 0 equals 3 times 0 minus 2, which becomes minus 2. Then U of 3 becomes 3 times 3 minus 2, which is 7.
Okay.
And this is actually a really common question in calculus 2 that they give you, which is like they just have you write the integral for some problems where you don't actually have to solve them. So just match this up here. I think that's the right one. Do you want me to give you one like this?
I'm sure. I'm still, so the -2 and the 7, you just plugged in
the bounds 0 and 3 into the U.
Got it. Okay.
Yeah.
Okay, yeah, we could do another one.
So can I give you one here to do? Sorry, I missed it. Okay. All right. So let's go with integral cosine 4x minus 7 dx from 0 to we'll go 5 this time. And I guess they gave you the U, so might as well give it to you as well.
All right. So okay, so once I get to the, I put 0 to 5. Oh yeah,
Well, you don't change the bounds. Like that's the last part.
Right, so 0 to 5 and then cosine u du over 4.
Well, I'm sorry, don't even write the bounds. I wouldn't even
Oh,
put them.
okay.
D over 4. And then you have to put 0 in for x and then the 5 in for x also.
Okay, so 4 times 0 minus 7, so that's minus 7, and then 4 times 5, 13. So then it's negative 7 to 13
Yes.
cosine. You plug back in the u
Yep.
for x minus 7. Do you leave the du over 4?
You can put the 1/4 out in front. With multiple choices, you know, you're matching it to what you see. So you want to do it the way that they present. So one of the things that this exam does that may or may not be helpful for us is it's in no particular order.
Right.
Maybe I should do this differently. Maybe I should give you a sample problem without the multiple choice and then have you try one with the multiple choice. I think that sounds better. So let's say y equals x to the 5th plus 3 to the power of 4. It says find dy dx. So this is power rule followed by chain rule. It's power rule because that's the outermost function. So your dy dx is 4 x to the 5th plus 3, subtract 1 from the exponent. And then you have to take the derivative of the inside function here, which is 5x to the 4th. Now, because it's multiple choice, this answer probably won't be correct. It'll probably simplify. So like you can multiply these two terms together to get 20x to the 4th, x to the 5th plus 3 cubed, something like that. Any questions on that?
Okay, so you just okay, yeah, that makes sense.
Okay, so this question I just did is the different numbers, but in kind of a different exponents and stuff, but it's the same process. You got to be able to take a derivative using the power rule and then chain rule.
So 2 a
8x cubed times 2. Yep, that's right.
It's so much. Wow. See, when I see it done first, I understand, but then I forget.
Yeah. Not really sure if these are actual AP problems. Okay. I was working with a student that had some really awkward, challenging problems that just seemed wrong, but that's okay. So the tangent of the function f of the point. No, let's not do that. Let's go. Okay. So it'll say where is f of x equals x e to the 3x concave up. So
Okay.
concave up refers to which derivative?
First.
So
No.
increasing and decreasing is the
So second.
first.
Second.
Yeah. So that means you got to take two derivatives of this. So first derivative is your product rule. So it's the first times the derivative of the second plus the second times the derivative of the first, like this. And then what I would do is I would actually simplify this a little bit. I would write as 3x e to the 3x plus e to the 3x, and then take a second derivative.
Okay.
Questions on before I know I'm moving a little quickly, but
Yeah,
we can
so
go back and look.
You just brought the 3x down and then you kept the e to the 3x and then, okay. Yeah,
Yeah.
that makes sense. Because the e's
Okay.
stayed the same.
Yes. Yes. So the next thing is we've got to take the derivative of this previous term, which is product rule. So it's the first times the derivative of the second, which is itself times 3, plus the second e to 3x times the derivative of the first, which is 3. Plus now we have to take the derivative of this thing, e to the 3x times 3. So again, these first two terms, they come from the first term here.
E to 3x. Why? Oh, the times 3 is because of the chain rule?
Yes.
Okay. And then, okay. Yeah.
So some simplifying here, this is 9x e to the 3x plus 6e to the 3x because there's 3 here and 3 here.
Mm-hmm.
So you now set it equal to 0. Okay, and you factor out whatever you can factor out from both, which is 3e to the 3x.
Okay, so then you got e, yeah. 2.
0. And so you set each of these equal to 0.
How do you do 3e?
So this is never 0.
Okay.
E to the anything is never 0. The one on the right is minus 2/3.
Okay.
Okay, so now you put that minus 2/3 right here in the middle, and you test points. So you might test like -1, and you might test like 0, and you're testing it back in this line right here. So the 3e to the 3x, it's always positive. Doesn't matter what number you put in there. I mean, you can verify that if you want, but it's always positive.
Mhm.
So when you put 0 in, 3 times 0 is 0, plus 2 is 2. 2 is positive. A positive times a positive gives you a positive.
So is the 3e to 3x, so whenever there's an e, it's never 0, basically?
Well, but like, let's say it was -3 out here, then it would always be negative. But the e part is always positive.
Okay, but because
Like,
the 3 is positive.
yeah, like e looks like this. So it's always positive.
Okay.
Okay, so then over here at -1, that's positive, but 3 times -1 plus 2 is negative, so it's negative here.
Got it. Okay.
So as a result of this, we go back to like, what is the original question? The original question was asking, where is it concave up? It's concave up from minus 2/3 to infinity. Concave down from minus infinity to minus 2/3.
It's a lot of work for one.
It is,
problem.
it is. And it's all based on your speed to be able to find find your first and second derivatives. If you knew you were going to get this question, there's ways to sort of pattern the answer where it's always a certain thing, but so we could either do the same problem, or I can change this to where is it increasing or decreasing, because that's only the first derivative, or you can do the second derivative. Do you have a preference? Do you want to do exactly the same problem, or like an increasing, decreasing?
Maybe increasing, decreasing, because that's the first.
Okay, so let's go decreasing, and that's f prime. So go ahead and give f prime of x a shot, please, on your own.
So the 2x comes down. No, just the 2 comes. Wait, does the 2 come down or the 2x?
The derivative of 2x, which is 2.
Wait, but in front? Because isn't it usually the number up top comes down?
So it's the derivative of e to the 2x is itself times 2.
Oh, you don't bring the, like, it's not like 2x.
No,
in
that's
front? Okay.
that's like x squared. You bring the 2 down. This is e to the 2x.
Oh, okay, it's different. Okay, sorry.
Yeah.
And it's e to the 2x. Okay, and then you do your number line, right?
Yes, I would definitely make that.
Oh wait, you have to set it equal to 0 first.
Did you get the full derivative? This is the full derivative here.
Why is it plus e to the 2x?
So it's product rule. The first part is u v prime plus v u prime.
Oh, and the u prime is just 1 because it's x.
Yes, yes.
Okay. So then x e to x times 2. So then the e to the 2x is always going to be positive.
Yeah, like you factor out the e to the 2x and you get 2x plus 1.
Yeah,
And that's where you have to set this equal to 0.
right. So the e to the 2x is always going to be positive, and then the
Mhm.
2x plus 1 equals 0. So 2x equals -1, x equals -1/2. So then you do -1/2, and then you have to choose points on both sides. So then do you test those points with the e to the 2x also, or just in the 2x plus 1?
Well, this was trying to explain is that this is always positive. You can put any number you want in there.
Right.
So the sign is really based on whatever is over here on the right, the 2x plus 1. Like it follows that. And because if you have a plus times a plus, well, it's plus. If you have a plus times a negative, it's negative. So it really just follows the sign of the second thing.
What, like, so if you plugged in, you mean like 0 on that?
Yeah, but so e to the, like, I know that this is a student is what you want to do. You want to plug in 0 for x, which is fine. I mean, it's right. And that's 1, but it's positive. Like you can look at it as 1, but it's a positive number. Because you only care about.
So you're saying on the right side of the number line is positive, and on the left side it's negative, basically.
Yes.
Okay.
Yes. I mean, maybe now you will appreciate this even more, is that the graph of 2x plus 1 looks like this. That's 2x plus 1. So see how it's above the x-axis over here and below over here? And that's why it's negative on the left and positive on the right.
Got it. Okay.
Because it literally hits the x-axis right there.
Okay. So then it's.
I feel like there's still some uncomfortableness with derivatives using the product rule. So I'd like to do a problem or two with that. Is that okay?
Yeah,
But in terms of the answer to this, it's decreasing from minus infinity to -1/2. So it's this one right here.
Okay.
But let's look at something like this. Like, let's say I give you x squared natural log of x, and I ask you to find dy dx. And this is a product rule problem. So the first, like, this is your
okay.
u and this is your v. Like, you have to be able to break it apart like that, either visually or write it out this way.
So then it's 2x ln x plus 1 over x squared? No.
So the way you did it, which is fine, is you did v prime u, but then you have to get v u prime. Or I guess I got those.
Oh, wait, I usually do it the other way. I don't know why I did it.
Yeah. Yeah. See, it doesn't really matter ultimately because you're adding, you can add numbers in any
So
order.
it's x squared. Okay, so 1, yeah. And then would you do anything with that x squared?
Yeah, absolutely. So you would reduce here. You get 2x natural log of x plus x.
Okay.
As your dy prime. And then a common question to ask is like more like this. It's like, what is the critical point for y equals, and I'll just change this slightly, x natural log of x. No, no, sorry, let's just do x squared because it's the same one. So you got to take the derivative, which we already have, 2x natural log of x plus x, and you set that equal to 0.
Okay, so then you bring out an x. No, you can't bring out an x. Well, you can't really factor anything out of that.
So you can factor x out of both. So 2 natural log of x plus 1.
Wait, you can do that even though it's 2x?
Yes, yes.
Oh.
You know this. You really do. Like, this is, you just maybe haven't done math in a while. Because if it's in both places, you can factor it out.
But I thought it was like not like connected to the 2 essentially, so you can't like.
It's, I mean, the analogous problem here is it's like 5 times 4 times 3 plus 4. You can factor a 4 out, so it's 5 times 3 plus 1. Because it's in the same spot. Or it's in both, I should say.
Okay. All right, so then x plus 1.
So you said x equal to 0, and then you said 2 natural log of x plus 1 equal to 0.
Yeah, so then I set the 2 ln x plus 1 equals 0, but then you get like.
This is where you got to remember how to undo ln.
Right.
Which is with e.
Oh yeah, okay, so e to ln.
And this is a very common question on kind of style where you have to reuse some of those trig skills.
Then the critical points are those.
Yes, yes. Okay. All right, so one more kind of product rule-y type question. So let's say y is x squared cosine 2x wants you to find dy dx. So my preference is to keep the first and take the root of the second, I guess. But it really doesn't matter, but you got to be able to take the derivative of both of them. Derivative cosine is minus sine. But then you have to multiply by the derivative of the inside function, which is 2, plus keep the second derivative of the first, 2x cosine 2x.
Okay, yep.
So then you get minus 2x squared sine 2x plus 2x cosine 2x. It's kind of the same as the last problem. What can you factor out of both? What is common?
2x.
2x. You could maybe argue a negative 2x. That's where it gets a little weird with multiple choice. But yeah, let's do the 2x. So it's 2x minus x sine 2x plus cosine 2x. But here's how it probably would be presented in a multiple choice situation. They would switch the order, because you tend to put the positive one first because it looks better.
Right.
Yeah, certain things just fit our eye like that. So if you understood that, if you think you got a good handle on that, there's one kind of just like it here that I can give you to look at.
It's cubed. Is it E?
It's definitely one of these last ones here. So I get 3. What did I say I would do? No, I wouldn't do it that way. I would do it the other way. X cubed cosine 3x times 3 plus 3x squared times sine 3x. So yeah, you could factor out a 3x squared from both, and you get sine 3x when you reorder it plus x cosine 3x. Yeah, looks like it's letter E for that one.
It's coming back to me now. Just need a
Good.
little bit of time.
Good. Some of these are probably too difficult for me to like try to make up new ones. So let's look at this next one together. All right, so it says at each point on a graph, the function has a slope equal to 4x minus 4. Okay, so they're telling you that this equation right here is the slope equation. Slope is another word for derivative. So what is the antiderivative of this?
4x squared over 2 minus 4x.
Plus c.
Plus c, yeah.
Plus c. So that's your f of x. Now they give you a point right here. They tell you 2, 3. All right. So I mean, at this point, you're down to maybe this one, actually, yeah, or this one. We can get rid of those two. So do you remember how to find the constant when you're given a point like this? Like this is literally x and this is literally y, or f of x if you prefer.
Yeah. Do you just plug it in?
3 equals, yeah, 2 times 2 squared minus 4 times 2 plus c, but you gotta solve for c.
Right. Okay, so then that's 3 equals 2 times 4, so 8 minus 8 plus c, so c is 3.
C is 3,
So then
yeah.
it's D.
Yep. So, I mean, this problem can be presented in a variety of ways. Like I could, for example, tell you to solve the initial value problem, which sounds really scary because it's like, what is that? Dy dx equals 3x squared minus 2x if y of 0 equals 4. And this is actually the exact same problem as the previous one. You have to find the antiderivative of this, plug this in for x and y, and find your c value.
3x cubed over 3 minus 2x squared over 2 x cubed squared. And then 4 equals. So it's 3x squared minus 2x plus 4.
No, you got to get the antiderivative. Your y is x cubed minus x squared plus c.
I did that.
Okay, because I heard some of this. Maybe you didn't mean that, but it's 4 equals.
Yeah, so then 4 is c, and then don't you make? Oh, you put it back with the anti.
Yes.
Oh, okay, I found the right c. I just put it with the original, not the anti. Got it. Okay.
All right, so the next type of problem I'm seeing here, we can, I guess I'll just snip this in. Can you find, okay, let's read it together first. The derivative of a function is given by, so they're giving you the derivative. Like you don't have to take a derivative. They're already giving you the derivative. I think that could be a stumbling block where you forget that when you're given the derivative and it wants increasing or decreasing, you just set this equal to 0. Okay, you don't have to take your derivative.
You just set the. Okay.
You set that as is equal to 0. 4 over x squared minus x equal to 0. This has the added sort of complexity that x cannot be 0, which is because you can't divide by 0.
Okay, so.
So like I would move this over, you get 4 over x squared equals x over 1. Cross multiply. And then take a cube root. So x equals the cube root of 4.
So it has to be b?
Maybe. Let me scroll up.
Oh, wait.
So the truth is though, like I'll get back to the answer in a moment. The truth is though, is if you're making a number line, you have to include 0, not because it's a critical point, but because it's undefined. There, and you really are supposed to test everything.
How do you know what the cube root of 4 is?
It's a great question. Well, it's more than 1 because 1 times 1 times 1 is 1, and it's less than 2 because 2 times 2 is 8. So it's somewhere between 1 and 2. Yeah, which means you can try 1, and you can try. You don't have to get that close. You could try 2, but I would maybe try 3, try -1. Now you're testing this in this line right here. Your g prime of x is 4 over x squared minus x. This one you actually do have to give a little more effort. Like when you put 1 in, you actually want to get the number. So 4 over 1 squared, 4 over 1 minus 1, that's positive. 3 4 over 3 squared is 4/9 minus 3 is negative. And then over here, you get 4 over 1 plus 1. So that's actually positive. So I don't know, what was it asking for increasing? So it's actually increasing all the way to
negative infinity to.
yeah, but that's actually wrong. It should be excluding 0. I mean, this was just written by someone that probably didn't take the time to look at all the possible solutions. Okay, let's look at another problem here. Integral 0 to 1 e to the minus 2x dx. So no calculator, so you can't just go and use Math 9. But what do you see here? Do you remember how to find the antiderivative of e to the u? Do you? This is one of those rules.
Well, e is always the same, right?
That's right. It's actually, though, it's e to the u divided by u prime. Which is kind of a weird thing to look at, but like let's go backwards. Well, let's just try it here. So the antiderivative is e to the minus 2x over, what would be the derivative of minus 2x?
Minus 2.
Minus 2. Now, if
and
you
evaluate it at the
but let's see why this works. So what is the derivative of, let's just say off to the side here, I told you y equals minus 1/2 e to the minus 2x. The derivative of this would be, well, you would keep the minus 1/2. E is the derivative is itself times -2 times the derivative of that, which equals these cancel, and you get e to the minus 2x.
Okay.
Now, if you don't like that, you have to do a U substitution for this problem, but it's kind of unnecessary. But let's look at that as well, just in case you want to go down that road.
Wait, I'm confused. Why can't you just do e to the negative 2x over -2 and then evaluate it at 0 and 1?
You can, but I guess the question is like, will you remember to do it that way? Will you remember this sort of specific antiderivative rule?
Oh, I see. Okay.
And if you don't think you
don't, then you do have a U substitution, is what you're saying?
Yes.
Okay, so let's run through the U substitution thing just in case.
Yes. So yeah, indulge me on this one for a moment here. Minus 2 dx is du over -2. So you have integral e to the u du over -2. Now remember what we did in like those first few problems, we put the bounds in.
Yeah.
Okay. So that's u of 0 equals -2 times 0, which is 0. U of 1 equals -2 times 1, which is -2.
Would it be the opposite way around though?
I'm sorry?
Don't bounds, wouldn't the bounds be the opposite way around because it's -2 to 0, not 0 to
it can actually be like, generally problems are given this way, like they are here. When you change the limits of integration through this substitution, they can flip. But what you'll notice is this negative here, you could use to flip it as well.
If you bring the negative out in front.
Well, instead of, but the negative would tie into these two. Like they would cause it to go from -2 to 0 and 1/2 instead of -1/2.
Oh, okay.
So there's a lot there. Like, I like for this particular problem, I think it's easier just to know this on the top right, but the general U substitution is you do this. So the antiderivative of e to the u is e to the u, and you evaluate from -2 to 0.
Well, does that get you the same answer if you would do e to the -2x over -2 at 0 to 1?
Yes, and I'll show you that in a moment here. So it's 1/2 e to the 0 minus 1/2 e to the -2. So this becomes e to the 0 is 1, so it's 1/2 e to the minus 2 is sometimes written as 1 over e squared. So this is one possibility.
Okay.
So going back to your question, which is e to the minus 2x over minus 2 evaluated from 0 to 2, 0 to 1, 0 to 1, yeah. This becomes e to the minus 2 over minus 2 minus e to the minus 2 times 0 over minus 2. Let me just see if I can grab this to move it down a little bit. Yeah. So what does this become? Well, the one on the left here is the negatives in the bottom always make it weird. It's negative 1/2 e to the minus 2. These negatives go together, so it's plus e to the 0 is 1/2. So if we flip the order, 1/2 minus 1 over 2 e squared, you get the same thing.
Oh. Yeah, I'm really bad with U substitution, so maybe
We get, well, the one that's given is just like it. So let me snip that in here. A little shocked that you have to do a AP final, even though you're done with the
I mean,
class.
only me and one other person didn't take the test, and still everyone has to do the final.
A lot of effort.
Yeah.
So this one's really similar. If you want to try this one here on your own.
Okay, so then it's e to the negative 3x over 3. I'm getting C.
Okay, so let me work this out. Did you use a U substitution, or did you just use the
Little rule.
the special case? Yeah. Okay, evaluated from 0 to 2. So this gives you e to the minus 6 over minus 3 minus e to the 0. It's effectively 0 over minus 3. So what I see is these cancel, making plus. So this is plus 1/3, negative 1/3 e to the minus 6. So when you look at the answers, that's where you got to decide whether to change this or not, and then you just flip the order. So it looks like it is C there.
Cool.
All right. Next question I see. All right, so we've not done a quotient rule yet.
Okay. I think I remember this, so I can try it.
Yeah, give this one a try. It's U. It's got the U over V. Are you given a reference sheet for this, or just all?
No, I don't think so. I'm gonna ask him about that though. I can ask him.
Okay.
Okay, so it's bottom times derivative of the top, so minus top. C again.
That looks right. These always simplify pretty nicely. I put the formula up here. Pretty important to figure out whether you're going to get, formula sheet or not. I mean, on the AP, you don't, as far as I remember.
I'm sure it's probably just like what the, like the formulas that they give you on the AP.
All right, minus, so what happens in this case where there's always a, when you have a, I don't know what to call it, like a linear over a linear, the variables always cancel out. So yeah, this one is -7 over 4x plus 3 squared. And just in terms of our sign chart, just the kind of like, I'll leave you with this last point. We wouldn't do one for this, but when you look at this, the top is always negative and the bottom is always positive. And so like, it wouldn't matter what number we put in here because you're always going to get a negative on top over a positive on the bottom.
So it would always be a negative number.
Yeah. And that's the kind of stuff you're looking for to help speed it up.
Right.
That would be, kind of a big takeaway. Do you get a copy of the chat when we're all done?
I don't think so. Like when you send the screen recording?
No, just like I sent you the chat. I want you to have the.
Oh, I'll just click on it and save it right now.
Yeah, that's the one I've been working from. We didn't get through anywhere near all of it. So it's I think it's a good resource. I skipped some questions that were more word story problems because they just take longer to do.
Okay, I'll keep the link, and I'll also for tomorrow, but I think I have one scheduled tomorrow. I'll send you some stuff that we worked on in class.
Okay, and I open up some times on Sunday in case you wanted to reschedule your Monday. I'd forgotten that I'd accidentally closed it off. So Sunday's available if you want to reschedule. Okay, well, thank you again. I'll see you tomorrow. Have a great night.
Okay, thank you. Bye.
Bye now.